Welcome everybody to another Big Brain Puzzles. This is MBW, the Megabit Warrior, and today James Sinclair made another puzzle for us to play, not us specifically, but for everyone, for you guys, the fans. And I just noticed I didn't put the lighting. Hold on one second. Stay up, lights. Okay, there it is. Ah, okay. I'm a little bit more lit up. It's lit in here. Yes, this puzzle is called Studious, and it's going to be a lot of fun. Hopefully it doesn't take me hours and hours, but you guys are with me to the end, right? Even if it takes 3 days. That's why I have this energy drink. Anyways, let's go ahead and go through the rule set, and I'll go ahead and explain all the things. So this puzzle, again, it's a Sudoku variant puzzle. Normal Sudoku rules apply, which means that every column, every row, and every 3x3 grid separated by those thick bolded lines have the digits 1 through 9, and they cannot repeat it within the column, row, and grid. And that's normal Sudoku. And all clues are standard. I don't know why it has to say that, but so arrows. The sum of the digits along an arrow is equal to the digit in the connected circle. So say, for example, this arrow right here is equal to what's in the circle. So if this was a 1 and a 7, then this, of course, would be 8. German whispers. Along green lines, digits differ from their neighbors by at least 5. So say, for example, if this was a 9, that means this has to be at least 5 away. So it cannot be 6 because that's only 3 digits away. Even can't be 5 because that's 4 digits away. So it would have to be a 4, 3, a 2, or a 1. And of course, from here, then it needs to be 5 digits from the 1. So let's just say it's 7, and then 5 digits from here, it would be 2, for example. Like that. Like this is a actual, like what it could be, for example, because it's at least 5 digits away from each other. And that's what the German whisper is, which is those green lines. Renban lines. So these are the purple lines, the hot pink ones. And they contain a non-repeating set of consecutive digits in any order. So that means, let's just say if this was the digits, there's 6 of them right here, so digits 1 through 6. That means this has a consecutive order. However, they don't need to be necessarily in that order. That they don't have to say like 1, 2, 3. They could be 1, 2, 3, 4, 5, 6, just as long as everything in here is consecutive. And of course, for more puzzles like this, go ahead and go to that website. Yeah, those are the rules. So we're going to go ahead and start playing. But of course, if you want to play the puzzle, I'm going to leave the puzzle link to the. I'm going to leave a link to the puzzle in the description. Go ahead and click on it so you can play alongside. You can play, pause this video and play it yourself, and just have fun with it. These puzzles are awesome, and we're gonna have fun. So let's go ahead and put the timer on the clock or on the board right there. Let's go ahead and start. So, where to start? I mean, the first thing that I would do is, so the Renban lines, or sorry, the German whispers, rather, the green lines, have to have a digits of at least, like they differ between 5, right? So it goes from like 6 to 1 and blah, blah, blah. It can never be a 5. And we know that because 5 minus 5 is 0, or 5 plus 5 is 10, which is not within those digits 1 through 9. So we know that these do not have a 5 in it. So the 5 has to go somewhere on this row in this grid. Same thing here. The 5 would have to go somewhere here. My guess is this sees this, And again, it can't be on a green line, so we have a 5 here. And because the 5 is taken in that row and in that row, that means the 5 has to be up here. Same thing here. That's as much as we're going to get. Yeah, I guess that's as much as we're going to get on that. Let's see. So, I was going to say, if this is a 5, that means this would have to be low numbers. Like, it would have to be 1 through 4. Actually, in general, I was going to say, like if this is a 5, it would be 1, 4, because 1 plus 4 is 5, or 2, 3, because that would be 5. However, we do need a... Oh, this would be interesting. Let's see if how this works out. We know that if this is low or if this is high, like it's like a low number, 1, 2, 3, or 4, 5 away from it is going to put it to a higher number. It's going to be the 6, 7, 8, or 9. On the next one. So if this is low, that means this is high, low, high, low, high. And same way here, if this is high, this would be low, high, low, high, low. So with that known, we have 3 of the high digits and 3 of the low digits taken. Now, if we're looking at this number grid right here, that means that there's only 1 low number and 1 high number left to be in this row, as well as the 5. So, my guess is that the high number has to be here, because you can't have a high here and a 5, because that would go over. So this would always be like a higher. What sucks is we don't know if this is how this is. So I mean, let me mark them as different colors. That's a horrible color to choose. Okay. Hopefully you can see it that way. So we don't know which route they're going to go in, but we know at least this will be a high. Same thing here. I don't know what I don't know. I can't really do the same colors though, because I don't want to get confused saying that this has to be the same color as this one. Like, so maybe we'll just do that. I don't know. I don't know why I'm doing that. It's just, that's the way it's going to be. So that means this has to have a lower number. And this can never be 5. Because again, it would have to be low, low in order to get 5. And we know that there has to be a high number down here. So this can never be a 5. So in fact, whether it be a 1, 2, 3, or 9, we at least know that this has to be a 6, 7, 8, or 9. Okay. What does that mean, though? What does it mean? What does this double rainbow mean? What it means, folks, is that I don't know. Sorry, hold on a second. Maybe the ends of these have something to do with, because one of them is going to be high, one of them is going to be low. So I'm just going to show you, because I'm guessing maybe we have to go this route. These digits right here can never have a 4 or 6 here, and I'll show you why. If this is a 4 or this is a 6, and vice versa, whichever one it is, the only thing that's 5 digits away from it is a 1 right here. Anything from here is 5 digits, is a 9 next to a 4. However, there's another connector to the 4 and the 6. So the only solution that this would have to be a 9. However, there is already a 9 in the row and grid. So we can never have a 4 or a 6 in the middle because the only solution is to have those duplicates. So the only place we can have a 6 or a 4 in these two rows is here, so that we can basically do this, right? Now, what that means again, we have to have a 5 here. If we have to have a 5 here and we have the 4 down here, because again, 4 can't go here, this would have to equal 9. So it would take these 2 away. Which I think is still possible, yeah. And vice versa. If we have a 1 down here, this would have to be a 6. You know what this can't be, though? Oh, never mind. It wouldn't be able to work anyways. I was going to say it can't be a 1 and a 2, but there has to be a 5 in there, so never mind. I should probably say that this is the case. Ignore those red ones. I'm just kind of showing how this looks right here. But the digits can never go outside of a 1, 2, 3, 4, 5. I wonder, let's just say that this is a 9, which means a 4 is here. Can we do it where this has to have like a 7, 8 here? Because again, 9 has to be down here. I'd have to go this way. Oh, what am I doing? I'm trying to see if, like, if the 9-4 here is here, we'd have to have something similar to this, because this would have to have the 2 and this would have to have the 3. And it's only like that because, like, in other words, the 3 can't be next to the 7. That's what I'm trying to point out. Like, in this whole scenario, 3 would have to come here. And it can never be here. Hmm. Huh. I think that's the only solution that it can be. Like again, if this is a 6, because we know at least a 6 or a 4 have to be here. Because again, if this is a 6, this is taking the 5-1. But if it's a 9, I guess what I'm trying to say is, like, I don't believe we can have both low numbers here. Like, it has to be one or the other. Like, if this is a 7 or an 8, for example, yes, the 3 can be there, but, like, can this ever be like a 4? Oh, actually, maybe it can. Maybe this still can be a 9. Oh, that does work. Because then the 3 is down there, 5, 3, 8. Oh, that did work. Actually, I didn't think that was going to work. Okay. Well, let's go ahead and get rid of that bookmark there, or pencil mark. I mean, the same thing is going to happen here, so I'm just going to label it like almost the same exact logic here. But again, we don't know too much more on that. Interesting. Quite. Okay. This is gonna go back and forth 2, but most it can be is 2, so it's fine. Or, 1, 2, 3, 4. So even if this is not a 6 or a 9, we at least know that one of the 4s or one of the 6s or both of them are here. But at least one of them is. So if one of them is here and it's seeing this entire column, that means this is also seeing a column. This might be where this may be the logic that we're looking for. Because again, one of them has to have one of these. I'm just penciling it like this for a second. I'm going to remove it in a moment. But let's just say yeah. This is seeing this column, this, and these two are seeing this. So this entire Renban is in the sights of these ends. And this is going to have that same type of logic. So this has a run of 6. So basically it's like 1, 2, 3, 4, 5, 6, right? From the other end, it goes 1, 2, 3, 4, 5, 6. Anyways, in other words, we know that there's at least a 4 in here, a 5 in here, and a 6 in here. We know for sure that the 4 and 6 cannot both be in the same area. Like one of the 4 has to be here and then 6 be here, or vice versa. They can't be both 4, 6, because that means none of these can be 4, 6. And again, that means the only option we can put them is here. But if this is 6, this has to be a 1. And this is 9, that means this has to be the 4, but there's not going to be a 6 in there. So, in other words, they have to be split up at some point. Like here. So we're never going to have both of them here, in other words. Just one of them. So if we know that one of them's here, and one of them's here, that I guess that would say that in the rest of this column, there is no a 6 or 4. Because again, if there has to be a 4 or 6 right here, let's just say 4's here. It means the 4 has to be here in one of these. But the 6 can't go here, so the 6 has to go here. So that means, yeah, this can never be 6. So anyways, in other words, this can never be 6. This one. So we know that this can never have a 1. Because of that, we know the 1 has to go somewhere here. Because we know the 6 has to go here. Phooey. Oh, you know what I did say? this is a 4 and this is a 6. That means 4 can't go ever be here. So this can never be a 4. Only possible places this can be a 4. So, in other words, only place this can be a 4 is here. And only these places can have a 6 in it. My God, I'm like fading. For some reason, I'm getting tired. Ugh. I just drank an energy drink. Okay. I know this has to be relevant here. Like, this has to be super important, like what we just did. We just proved that this can't have 6 in it. What does that do for us, though? That's what I'm not sure of. Like... what does it do for us? This is interesting. We know that these two have to have a low number somewhere in there, right? Because this has to have a low number in there, these are seeing this entire line right here. If that's the case, and because 5 in those two grids are here, this whole line never goes from low to high to low consecutively. It always has a low or a high. So this is going to be the digits 1, 2, 3, or 1, 2, 3, 4, or it's going to be 6, 7, 8, 9. This line. If it's all low, what possibilities can this be? Like, say for example, if this is a 7, so if this is like a 3, 4. If this is a 3, 4, that means that the 2 and the 1 would have to be here, right? Which means the 3 and the 4 would have to be here. But does that dictate what happens over here? Because then that would have to be a 1, 5, 6. Right? Like, in other words, that's how I see this. Like I see this is going to be crucial to this linking up with this one. Now, I'm not saying that this is right. I'm just saying that like that's how this is linking up. And vice versa. Like if this is a, let's just say this is a 5, 3. Oh no, we know that there's a 3 in it. A 5 in it. Sorry. So yeah, this can't just be a 2, 3. Sorry about that. But you got the same gist. This has to, like, it's going to link up to here. But anyways, if this is like a 5, 3, for example, we just know that 3 can't be here, so it has to be somewhere here, right? Same thing here. Since this has to have a 5 in it, if this one had a 2 in it, then we know that the 2 would have to go down here, for example. So either way, no matter what these digits are, if it's low, high, whatever, it will be opposite of this one. Because every single low number is seeing this, and it can't be a 5, so this is opposite. So in other words, if this is all high numbers, that means this has to be a low number. Oh, I could do one better over here, can't I? Since I said that this, like, these had to have the 6 and 4. I said this went away from 6, and then so this therefore had to be 6. So this can't be a 6. So in other words, this always has to have the 4 in it. This always has to have the 6 in it. So the 6 is seeing this. So the 6 cannot go here. Oh, 6 has to be here. All right. I was going to say we got our first digit, but we had the 5 a long time ago. Perfect. So that means that this is a 5-1 right here. A 5-1 pair or 1-5 pair. Cool. I don't know why I wanted to say cool like that. Cool. Okay, so 4 is seeing all this. So that means 4 has to be here. Because again, 4 is seeing these ends, and the 4 can't be in here, and it's not there. So this is a 4-5 pair, which makes this 9. Nine has to go here. Okay. All right. So same thing here. If this is high and this is high, and let's just say this was high too, 6 can go down here, 9 can go up here, 7, 8. So that does work. I'm not going to label that as a high or a low just yet, because we don't know. But it is cool. Okay, so 9 is seeing this. We don't know if 9 is on here, because this could be a segment where it's like, 9, 8, 7, 6, 5, 4. Because I was going to say if this is not 9 and it can't be 9 on here, and this is seeing it, and this is an arrow, which a 9 can't be in the arrow, this would be 9. But I'm not saying that. It might be likely, but I'm not saying it just yet, because we have to prove that that digit is not here. So what will be interesting here, though, is when this is a 6 and this is a 1, coming back here, this would have to be, this can't be a 7. Like, if this is 6, this can't be 7. Because oh no, it can be 7. But can it not be 8? Is that what I'm trying to say? I guess I could. I'm really like losing my voice here. Okay. What I'm trying to say is like I know that the 8 or 9 have to be here. Like if this was the high, the 8 and 9 have to be here, and if this is the high, then 8 or 9 has to be here. But what I'm trying to prove is the 3 or the 3 has to be at the end all the time. Because if I have a 3 here, and either one of these needs to be an 8. Yeah, because basically, like, if this is a 6 and this is a 1, that means a 3 can only go in one of these places. The same thing here. If this is a 6 and this is 1, 3 can only go in this place. So let's just pretend it's this way. So if the 3 is here, and this has to be an 8 and 8 or 7, but it could be in any order. 7 is only 4 away from 3, not 5. So that's impossible. So this can never be a 3. So in other words, 3 is always down here. My guess is the same thing's going to happen up here. It's just opposite. So the 9 away from here, like to go that way. Seven, I want to say. Let's see. Okay, so if this is a 4, this is a 9. The only options I can do is a 3, 2, right? A 4. I mean, sorry, a 7 is only 4 away from the 3, so that can't happen there. Yeah. So that means the 4, 7 have to be here. Man, I'm getting tired. So no 7 here. Seven can go here. You know what? The 2 would always have to go here. Because still the 3 cannot be next to the 7. Whichever one it is. So this would have to have the 2 in it. So in other words, that's true. I did that wrong. Just get rid of the pencil marks. Okay. So same thing here. This would have to be a 1, 8. Is this good? Yeah, I guess that has to be right. Okay. Um, no. Maybe let's try this. Maybe something has to go over here because I feel like this is all good, but I don't know if we're gonna be able to break it down anymore than that. Like it's so good. But like again, if this is a 7, it sees all that, so 7 can still go there. Yeah, let's take a look at this really quick. Like 4, because 4s have to be at the end of this. Like, you can't have 4 on these two because then again, 9 can't go 2 times around it. So that's the only difference from 5 that there is. So 4 can't go here and can't go there, but 4 can go here. If this is a 4, that means the 4 is here, which makes this the 9. This 4 makes this the 9, but 9 is already there, so this can never be a 4. So 4 goes down here. And I am fading. Oh my god, why am I so tired all of a sudden? It's like I'm thinking in my head like of what to do, and then all of a sudden I'm like, whoa, what the heck? I just can't say for sure if this is gonna have a 4 up here. Or like, I don't like to pencil mark that much, but I want to for some reason in this case, so I'm just gonna leave it at that. Yeah, it's gonna leave it as that. Okay. What about 6? So 6 can go anywhere here. I think I could do the same logic here. So if this is a 6, that would make this a 6. 1 would go here. 1 would go here. Making the 1 have to go somewhere here. Why am I so tired? No, we can't have 6 there. This 6 cannot go here either, because then this would have to be a 1, but the 1 is here, so 6 has to go here. Don't know what that does for us. Doesn't do anything for us. 1, 2. Oh wait, 4. Actually, here it is. Here it is. Here it is. Bam, 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 bam. So let's get rid of this because again, that's if it was only if this was a 6. So I said earlier that this can't be a 4, and this can't be a 4 either because that would make this the 4 and this the 9, but then this would have to be a 9 also, so it doesn't go. So anyways, this is where the 4 is, right? Well, since 4 can't go here and 4 can't go here, that means none of this line is a 4. But because it can't also be a 5, it's never going to overlap, meaning all these are high digits. So in other words, and I'll clean it up in just a second, it's going to be either a 6, 7, 8, or 9, which the 6 is seeing this and the 9 is seeing that. So those are the possible digits that are in this location, meaning this has to be a low just because all of these digits are seeing this one. Can't be a 1, can't be a 4, so it's going to be either a 2 or a 3. Fascinating, right? Super cool. I liked it. I was going to say, is the same thing true here? Ooh, this always has to have a 6 in it. This always has to have a 9 in it. I just want to mark it because if this is a 9 and this is a 9, 9 has to go somewhere here. Yeah, so if this is a 6, that means this has to be a 6. So this can never be a 6 up here. So the only place that this can be a 6 is here. So if this is a 6, that's our 1, and that makes this down here the 3 and the 8, and that's 3 in the corner. That's 3 in the spot. Light. Losing my religion. Perfect. Okay, we got a whole bunch of digits right there. That was great. That was superb, as they say in the compliment world. Okay, so I think this has to be a 9. Let me just make sure. This is taking that. This is taking that. So yeah, this is 9. That means this is going to be it has to be either a, oh no, 1 is right there, and oh, so that means this has to be a 2 or 3 right here. I'm just gonna label the digits. I wanted to label that because that would make this one high. So can't be a 6, so it has to be a 7 or 8. And this is going to be a 7, 8, or a 4. I don't know yet. But what it does say is that this has to be a 2 or 3 here, because like, since this is seeing all this and these can't be the 2 or 3, this has to be the 2 or 3. So like this, these digits are the same, in other words. All right, anyways, this 9 sees this, so this is our 2. That makes that our 7. That makes that our 8. That makes that our 3, which is the 9, the 9-ish, and then the 4. This 2 is seeing that, so that's our 3. That's our 2, that's our 3. So interestingly here, 5 away from 3 is 8 and 9. This 9 is seeing this, so this is an 8, and this is a 9. Meaning this is our 9 up here. And this makes this a 7. So, since this cannot be a 7 because of it's on the line, this is our 6, 8 double, which sees this. That's a 7. So this has to be a 4 or 8. 8 is seeing this, so this is our 4. That's our 8. Cool. This is going to be a 1 or 2. Yeah, 2. And I'll label it for the shoots and gigs. The shoots and gigs, yeah. I guess we know that these are the lows and the highs. I was labeling these because, like, say for example, this means that our highs are all taken, so these are all lows right here. In other words, so say for example, this low, it might mean that this is an entire low information right here. Actually, it does, because the 1 goes here, like the 1, 1, 1, right? So that means this has to be a 2, 3. I'll just label those here. So the 5, 7, and 9 are going to go here. So what's interesting is this other 2, 3 is seeing this one. So if this is a 2 and this is a 3, this is a 4. This is a 3 and this is a 2, this is a 4. So this is always a 4, in other words. All right. 4, 5, 6. All right, cool. All right, so this is going pretty cool. Let's see. Trying to see if I can prove which one this is. I don't think, like, if this is a, I'm trying to say, like, can this ever have a 7 in it? But, like, no here, but it could here. Can it ever be a 9? No here, but it could here. So, like, there's always something preventing it, like, so I can't answer that question just yet. Oh, man. Why am I so tired? Bing. This digit's going to be the same. I'm just going to go here. This digit is seeing all this. This digit is never here, so it has to go here somewhere. I'm not seeing it. Can I still do can I do the 9 yet? Let me see. Can 9 can't have it there. So 9 has to go here somewhere. If there's a 1, that means there would have to be 4 of these have to be low. If I put the lows here, I was trying to see like how many lows would be in here. Like, can this ever be a low? Guess it does work. Bummer, I'm not seeing it. I think my air conditioning is off. Hold on, let me turn on the air conditioning. Yep, it was totally off. What do you want? I guess nothing. Okay. Anyways, I don't want to like pencil mark too much, but like 9, 9. Nine would have to go somewhere here. Oh, there's a lot of 9s in this row right here. So if 9 is here, 9 is seeing this, and this can never be a 9. So this is our 9 right here. Oh my god. That was an easy one. Which makes 9 right there. Okay. So now, perfect. Now we know that this is a string of 987654. So it's never going to have a 1 or a 3 in it, in other words. So I'm going to actually like label them like this just so that it's like easier. But this is going to have a 7. This is going to have a 4. 6 goes up here. What about 8? 8 is seeing this. 8 is seeing this. So 8 can go anywhere here. Five can still go anywhere, which is disappointing. But that's it right there. So I'm going to look at that and weep. Because we at least like know that there's at least 3 high numbers here. Which means like all these are going to be low except at maybe one of them. 9 here, 9 there. Those are the only 9s left. What digit can this be? Because this is showing the 879, right? So this can either be a 5 or a 6. If this is a 5, this would be like a 1 4 and a 2 3. 2 3 wouldn't work, so 2 3 would have to go here. Oh, check that out. So this would work if as a 5, and again, this would have to be the digits that it could be, right? It's either a 2 3 pair here, 2 3 pair there, or a 1 4 pair there, or 1 4 there. But these digits are the only possible digits, right? Well, this 1 4 is seeing this, so that means this can never be a 1 4 pair. The 1 4 pair would have to go here, just based on that logic, right? However, there's a 3 seeing this, so this can never be a 2 3. So if that can't be a 2 3, then this can never be a 5. So every single time, this is a 6, in other words. So the 6 actually goes here. Just want to see if there's anything that's doable here. Yeah, because 6 can't be on the same right here. So 6 is here. So 6 is going to go up here. Perfect. All right. So what digits can this be? It can't be a 3 because it would have to be 3 plus 3. Can't have a duplicate on a column or a row. So 3 is never going to be here. But what it is going to have is either a, I'm just going to label them and I'm going to fix it in a moment. But it's going to be 1 plus 5 or 4 plus 2. Now, this 4 is seeing this, so this can never be a 4. And if that's not a 4, this can't be a 2. This 1 is seeing this, so if this can't be a 1, this can't be a 5. If this can't be a 2, and it can't be in any of them, this can never be a 4 down here. So this always has to be the 1 5 pair, in which this can't be the 1 5 pair, so this is not true here. So that means this is our 4 and that's our 2, which is going to give us a little bit more up here, which is great and superb and wonderful. Ha 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 ha. This is the 2 up here. I'm just marking it because of the Sudokus. But because we labeled this up here, this is our 5 right here. This is our 1. That's 4. That's a 5. So now we know that 5 has to be down here. I'll go ahead and clean this up a little bit. But since the 5 is here, that means we know that this is the 8. And that means we know that this is the 7. So this is a 4 5 pair right here. Since this is the 4 5 pair, we know that this is going to be a 4 here. We know that there's going to be an 8 here because of Sudoku, because of these 8s. So this is our 8. 7 is going to go down, go right here. 2 is going to go right here. 3 has to go here. All right. Actually, we could start like marking a lot of these. So this is going to be a 3. One is going to go down here. 2. Eight. Okay. So that means, man, I'm still getting super tired. It's 8, that's a 6. So that here it is, 6, 7, 8, 9. So that works out. All right, so we know the 1, 7 is here. The rest of this is going to be Sudoku. I know it is. So a 3's done. Oh yeah, 3s are done. 2s are done also. 1s are quite not. Quite not. Actually, this might be a 1 right here, but let me just double check really quick. So the 1s. Oh no, this could also be a 1 right here. 4. Oh, 4 has to go here. Because that one's seeing this, and then these 2 are seeing that. So this is our 4, which brings us here. So now that's going to clean up that, and that, which brings joyous and friendship to all. Which brings joyous to all. You're so weird, guys. I think we're done, guys. That was a really good puzzle. I'm actually very proud that this didn't take us forever and a day to do. I know it took an hour, but like lately, my puzzles that I've been doing have been taking me like 2 hours plus. I don't know why I just haven't been able to like crack them, but like this one seems like I at least like move through it. Like, yes, I got stuck on some parts, but like I just had to like logic it out, and I was battling tiredness. Like I felt like I was like, for some reason I'm like wide awake, and then I just start thinking of if 6 goes here and this and this that, and all of a sudden I'm like, oh, my eyes are closed. What the hell? Even though I'm still working it out in my mind, I'm like, what the hell? But yeah, I really enjoyed this puzzle. I did like this uniqueness of like having to figure out that the ends of these correlated with this so much that like they ended up linking together, so that you know that the 4 and 6 have to be on this, because it has to be a digit 1. It's 6 digits long, so it has to have the 4, 5, and 6 in there. And once you know that, these ones are like linked together, and like that was cool. That was definitely like the main pivot of like linking those together, and then of course like just kind of seeing like which ones are high, which ones are low. No, I thought that was a really amazing puzzle. I always like James Sinclair's puzzles, so no, I really enjoyed it. But yeah, if you guys played it, what'd you guys think? Hopefully you guys did. I do these because I always I really liked watching Cracking the Cryptic. I still watch them actually, like especially Simon cracks me up every single time I watch his videos, and like I like that I was able to find these variant Sudokus through that YouTube channel, and I'm hoping that maybe at least like 1 or 2 people find these puzzles through my channel, because I think it's kind of cool to like share these amazing puzzles that people put together, and just share that joy to everybody. So I'm hoping that somebody played it. If not, hopefully you guys enjoyed watching me do this, because I'm going to do this every other Sunday here on this channel. Again, thank you guys so much. Like if you like, subscribe if you want to subscribe, and I will check you guys out next time. Again, lots of content on this channel. Please subscribe. It's great. But I will check you guys out next time, and thank you guys so much for watching, and stay tuned for another Big Brain Puzzles. Later.